evaluate the definite integral. And what does that mean? To get started, I'm just going to show you graphically what's going to be happening here. And then we're going to, of course, use calculus to find the value of this definite integral. So first I'm just going to graph y equals x squared, just a parabola with a vertex at 0, 0. I can probably do a better job than this. Yeah, that's okay, I guess. We'll do a job I wish was a little bit smoother. But, okay, so what is this gonna, what are we looking for here? We are looking for the area underneath the curve of y equals x squared and above the x-axis between x equals 0 and x equals 3. So x equals 0 here, x equals 3 over there. So what the definite integral is trying to evaluate is this area right here. You can see that my coloring skills are amazing, of course. So this is what we're looking for, and this is what we're going to be evaluating with calculus, with the use of the integral. So, okay, remember that the integral of x to the power of n is going to be x to the power of n plus 1 over n plus 1, because it's the antiderivative. And if we have an indefinite integral, so if we have no little numbers here, we're always going to add a constant. In this case, we're not going to need to add a constant because we're looking for the definite integral. We're just looking for this area right here. So what is our next step? Well, if we have x to the n, the integral of that's going to be x to the n plus 1. So we're just going to add 1 to the 2. So we're going to have x cubed over n plus 1. 2 plus 1 is 3 as well. And we're going to put square parentheses or square brackets here. And I'm going to take the 0, put it here. Take the 3, put it over there. And what does that mean? First, I'm going to plug in the 3 for x. So we get 3 cubed over 3. And then we're going to subtract this with the 0 plugged in. So we plug in the 0. So we have 0 cubed over 3. Okay? And this will give us the area underneath y equals x squared above the x-axis and between 0 and 3. So 3 cubed is 27. That's over 3. We're subtracting. 0 cubed is just 0 divided by 3, still 0. 27 divided by 3 is 9. 9 minus 0, just 9. Great. So this, the area that we were looking for is 9. Right here. Fantastic. But what if instead we were looking for the area between 1 and 4? How would we evaluate that? Then, of course, pick a different color here. We have a 1 here, the 4 over there. And we would be looking for this area instead. Wow, that's a very bright green color. Looks terrible. Okay, so but what would we do with the calculus or with our numbers here? We would have a 4 and a 1. So plug in the 4 first and then subtract the 1 plugged in for x as well. Hope that makes great sense to everyone. So we would get 4 cubed, which is 64, over 3, minus 1 cubed, which is just 1, over 3 as well. So the answer would be 63 over 3. And that would be, and actually that works out to just 21, doesn't it? It does. Fantastic. So that would be the area between 1 and 4, below y equals x squared and above the x-axis. Now, of course, I suggest you try more questions, watch a few more videos, and good luck.